there are multiple steps, we are going to simplify both sides of the equation, apply the addition or subtraction property of equality, collect the variable terms on one side of the equation. Apply the addition or subtraction property of equality to collect the constant terms on the other side of the equation. And then 4, use the multiplication or division property of equality to get a coefficient of the variable term equal to 1. What that says, let me break it down for you. What that really says is do PEMDAS backwards, right? Because you add or subtract first, then you have your multiplication. Add or subtract first, multiplication or division. We're not quite at the point where we have exponents or parentheses yet. Well, actually, we have parentheses, but not exponents just yet. I'm not going to do you dirty like that just yet, but get ready. It's coming. So, for number 5, if I'm solving for z, to solve means eventually I'll get z equals. So I need to, right, if I think of z as my bare foot, right here I've got socks and shoes on. I want to get barefoot, so we've got to take my shoe off first. So what would have been last for simplifying now has to be first for solving, so that means subtract over the 5. So I've got 7z equals what is -9 minus 5 is -14. Gosh, I need y'all here with me. Again, you should never trust anything I do in my head. And the next step, if this is 7 times z, what undoes times? Division. So we're going to divide by 7, so z equals -2. And there we go. So our answer is -2. Here for 6 and 8, you can do it on your own, but I'm also going to save it for the next kind of set of notes, which is the 9.5. I think it's 9.5. But we're going to cover these in the next topic, so just bear with me. It discusses how we get rid of fractions and how we get rid of decimals. So on to 7. Again, we know we're done with 7 if I can get just v equals. So my first thought to myself is, okay, self, is it cool? Am I cool with having 2 v terms? Not so much. So what I want to do is get all my v's on one side and my numbers on the other. I like my variable term to be positive, but it doesn't have to. But what I'm getting at is that I like to add the 2v over, and then I'm going to add the 20 to the left. So that I have 5 plus 20 is 25 equals 5v. So that's kind of the step 2 of the solving that I read through. So now 5 times v, I know I've got to undo times, so we're going to divide. So v equals 5. Ta-da! Okay. So now let's look at 10. I'll leave 9 for you, or make sure you get it from me in class. What I see here first is that I want to simplify. So I'm going to be simplifying simultaneously while I solve, and that's A-okay, no big deal. So I'm going to distribute this 2 and these -2's respectively, so that I get -5 minus 2y plus 10 equals 4y minus 2y minus 8 minus 3. So now I don't have any parentheses hindering me or in my way or just slowing me down. What do you think we're going to do next? We are going to combine like terms, keep simplifying, so that it looks similar to something like we did on the previous page. So on the left, I'm just going to simplify the left independent from the right currently. So -2y is what? Negative 5 and 10 becomes positive 5. On the right, we end up with, what, 2y minus 11, hopefully. Now I'm going to add the 11 to the left, add the 2y to the right, and we get 16 equals 4y. So what does y equal? 4, because 16 divided by 4 is 4. Ta-da! Yee, smiley face. Okay, suppose 6 is a solution to the equation ax equals negative 18. Oh, I cannot talk. Ax equals negative 18. Find the value of a. Well, if x is a solution, remember that means that x equals 6. So all we have to do is a times 6 equals negative 18, and now solve for a. So what does a equal? Negative 3. Whoops. A equals negative 3. So what I need you to take away from this is the statement right here, 6 is a solution, means x equals 6 in this specific situation, right? We can change a and x to be, I don't know, b and q.